Okay, so we're bringing together all of our knowledge really about quadratics and what these individual things mean and how they appear or how they're illustrated on the graph of this function. So the first thing we're going to find is the roots. Okay, the roots come from solving the quadratic equation equal to 0. Okay, the roots are the point where the graph cuts the x-axis, and at that point y, or f of x, is equal to 0. So you can write maybe in brackets to set f of x equal to 0. So we have to do that in order to get started. So it's x squared minus 3x minus 10 equals 0. Okay, we have to set that f of x equal to 0 because we're finding the 2 points where the graph has a y value of 0, basically. As I said, the two ways to solve this are either through factorising or through using the quadratic root formula, but we will never be using the formula when we're asked to sketch, so we'll always be looking to factorise. When you're going through your own example, you factorise this any way you can. It's x, it's a 1x squared, so it's going to be x and x. Then we're looking for two numbers that multiply to give me minus 10 and add to give minus 3. So right away I'm thinking 5 and 2 in some sort of way. One of them has to be negative to give me an answer of minus 10. So it either has to be minus 5 and 3 or 5 and minus 3. Now to get an addition answer of minus 3, it has to be minus 5. Minus 5 and positive 2. Multiply to give me minus 10, not 3. So it's x minus 5 and x plus 2. That's what that factorises to. Each one of these are then going to come down and we'll get our roots. So x minus 5 equals 0. So x equals 5. X plus 2 equals 0. So x equals minus 2. Okay, so that would be our two roots there. Now the turning point is the next thing. And that's going to be the midpoint. Find the midpoint of the roots. Okay, so the midpoint of the roots, so I want to find my x value for my turning point, which is the midpoint of the two roots. So find the average of the two roots. So 5 add minus 2 divided by 2. So that is 3 over 2, or 1.5. It's 3 over 2. We can keep it as 3 over 2. So x equals 3 over 2 is the x value. So now we need to work out, this is going to be slightly difficult to do, what the y value is when x equals 3 over 2. So usually it wouldn't be a fraction, but in this case it is. When x is 3 over 2, y equals... Now, so what we have to do is substitute this value of x into our quadratic to basically figure out the value of y, okay, or the value of f of x. Okay, it's the same thing. So just copy this down as I do it, please. So y equals x squared minus 3x minus 10. So we're substituting in x equals 3 over 2. So it's 3 over 2 squared minus 3 times 3 over 2 minus 10. As I say, it's usually not a fraction, so it's usually a lot easier to get this answer, but this particular example is a fraction. So square the top, square the bottom, so that's 9 over 4. Minus 3 times the top, so that's minus 9 over 2. And minus 10. This is kind of good practice though of working with fractions. We can change, to be able to subtract these, we need to change them all and to have the same denominator, right? So they all need to be something over 4. You have to form equivalent fractions. You have to get the denominators to match. So I can times top and bottom by 2 in this second one to get it to be over 4. So 9 over 2 is the same as 18 over 4. And this is kind of like 10 over 1. So I'm going to times the top and bottom by 4 to get it over 4. So minus 40 over 4. So 9 over 4 minus 18 over 4 is minus 9 over 4. And take away 40 again, that's minus 49 quarters. Okay. Which is minus 16 and a quarter. Right. That's a horrible answer, but that's only because the roots gave a mid value of a fraction. Okay, usually it won't be that difficult, so don't be put off by that. Okay, so what this means though is that the turning point, which is again, because it's an x squared graph, it is a minimum turning point. It's a happy face parabola, so a minimum turning point. So it's 3 over 2 for the x value and minus 49 over 4. So that's basically 1.5 and minus 16 and a quarter. When we actually go to plot that, it doesn't matter that, it doesn't have to be exactly a quarter of a way through a box or anything like that. It just has to be roughly right, and then as long as we mark on the value. Okay, that was the turning point and the roots. The axis of symmetry is an easier one to do. That's just x equals the x value of the turning point. So the x value of the turning point is 3 over 2, so it's just x equals 3 over 2. That's all we have to do for that. And the last one is the y-intercept. So to find the y-intercept, we have to do the opposite of what we did for the roots. We have to set x equal to 0, because we're looking for the points where it cuts the y-axis, not the x-axis. So take your original quadratic and set x equal to 0. As I say, when it's written out in kind of full form like this, it's dead easy, because it's f of 0 equals 0 squared minus 3 times 0 minus 10. So that's just 0 minus 10. So it's just minus 10. So that is the point 0 minus 10. Okay, so hopefully you're still with me here and you've copied all this down. So what we now need to do is draw a set of axes carefully. If you've got a ruler, can you please use it? If you don't have a ruler, that's okay, but try and maybe use the side of your phone cover or like a book, something like that. Try and draw a straight line, nice set of axes. Right, so 0, I've got my y-axis, I've got my x-axis. Right, my two roots, what were they? My roots were 5 and minus 2. So approximately, just mark on 5 and minus 2. Okay, it doesn't matter if they're not exactly the right way spaced out, but you just need to make sure that you put the numbers on. The turning point was 1.5, which is, about here, and then minus 16 and a quarter. 3 over 2 minus 49 over 4. So somewhere random, like down here. And then just put on that coordinate point. 3 over 2 minus 49 over 4. You must put the coordinate point on there. And then the y-intercept was minus 10. So roughly about there. So once you've got all those points on, we can now draw a nice smooth parabola joining those lines together. And I'll mark on the axis of symmetry, which was x equals 3 over 2. Okay. So, found the roots from factorising and solving. We found the turning point, which by finding the midpoint of the roots and subbing the x value in for the y, won't always be as difficult as this. We found the axis symmetry, just x equals the x value of the turning point, and the y-intercept is just setting x equal to 0. Let's try it again from the second question in the notes, okay? So example B, this is example 6B. So this is your quadratic that you need to do the same thing for. So it's f of x equals 8 minus x squared plus 2x. Now the first thing you need to be aware of in this quadratic is that it's not in the usual order, and that's because we have a negative x squared value. Now what that negative x squared value means is that it's going to be the opposite shape, right? It's not going to be a minimum turning point, it's going to be a sad face, so it's going to have a maximum turning point. But everything else should just be kind of exactly the same. So let's get started. Roots we're going to find first of all. So to find the roots, we have to set f of x equal to 0. So you do 8 minus x squared plus 2x equals 0. What we're going to have to do is factorise it. Now factorising a minus x squared is pretty horrible and difficult. So a way to get around that is we can actually shift all of our things over to the right hand side, and if we add x squared to both sides, that's going to actually change the minus x squared into a positive x squared on the right, and then we'll have 0 on the left, but we'll just have everything basically changing sign on the right hand side. So that's what we're going to do. So move everything to the right hand side, and it basically just changes the sign of every individual bit. So it'll go to positive x squared minus 2x minus 8. Which is a lot easier to factorise than a negative x squared. So we're now thinking of, it's going to be x and x for the first two things. We're thinking of two numbers that multiply to give me minus 8 and add to give a difference of minus 2. So things that multiply to give me minus 8 is going to be like 4 and 2, one of them minus, right? So which order does it have to be if it's going to give an answer of minus 2 when you add them? Just try it in your head. 2 plus minus 4, that's 2 plus minus 4, that's minus 2. Let's try it the other way. Minus 2 plus 4, that's positive 2. So it's got to be plus 2 minus 4. So plus 2 minus 4. Okay, so let's just double check that. Yeah, plus 2x minus 4x, yep. Minus 8, yep. Okay, now we just bring each one down. So 0 equals x plus 2. Move the minus 2 over, so it's just going to be x equals minus 2. I'm just rewriting it the other way. 0 equals x minus 4. Plus 4 to both sides, you get 4 equals x, or x equals 4. Okay, so that's my two roots found. Okay, let's move on to my turning point. So, find the midpoint of the two roots. This time, it's not going to give us a fraction, you'll be pleased to know. So, x equals minus 2, add 4, divided by 2. Minus 2 add 4 is 2, divided by 2, which is 1. So, the turning point has an x value of 1, so when x equals 1, what does y equal? So you go to f of x, and I should maybe stick to the terminology rather than putting y, I should say f of x, but you need to understand that f of x represents y. Okay, so y and f of x, they mean the same thing. So when f of x, we're doing f of 1, So a little bit of kind of functions practice. So 8 minus 1 squared plus 2 times 1. So just substituting 1 in for our x in our original function. So f of 1 equals 8, 1 squared is still 1, plus 2 times 1 is plus 2. So 8 minus 1 is 7, 7 plus 2, that's 9. So therefore, this time, remember, it's a maximum turning point because it's going to be like a sad face parabola. The turning point is going to be up at the top here. So the max turning point is x value 1, y value 9. Okay, so a bit simpler than the last one. We've done most of the hard work. Now we just need to get that axis of symmetry and the y-intercept. So they shouldn't take long. So axis of symmetry is just the x equals the x value of the turning point. So that's just going to be x equals 1. And it's done. And the y-intercept is the opposite of the roots, so we set x equal to 0. Because the y-intercept is the point where the graph cuts the y-axis, and at all of those points along the y-axis, x is 0. So it's f of 0. And that is 8 minus 0 squared plus 2 times 0. So all of those just turn into zeros, so the answer is just 8. So that is the point 0, 8 on the y-axis from our y-intercept. Okay, so I've got my roots, minus 2 and 4. I've got my turning point, 1, 9. I've got my axis of symmetry, x equals 1. I've got my y-intercept, 0, 8. I should now be able to make a fairly accurate sketch using all this information. So as neat as you can, draw 2 lines for your axis of symmetry. Sorry, for your axis. Oh dear, that's something's bad has happened to my line. Can I move this down a wee bit? Okay. So 0, that's the y-axis, this is the x-axis. So we mark on the roots first. So that was minus 2, roughly there, and 4, so just roughly about twice as far from the origin. My turning point was 1, 9, so that's roughly going to be up here. Just mark that point on, 1, 9. And the, what else? Axis of symmetry we'll dress in a minute. The y-intercept is 0, 8, so that's just this point here. So you can say that's 8. So I'm going to use a different colour pen just to kind of highlight it. So remember, it's a sad face parabola that is going through all of these points. So it's going to be a sad face kind of hill shape going through these points. Turning at 1, 9 and then going back down there. Okay, and then the last thing to do is just mark on your axis of symmetry. X equals 1. Okay, and that is the graph we should probably write on the, get in the habit of marking it on. That is f of x, that is 8 minus x squared plus 2x. That is the graph of 8 minus x squared plus 2x, and that's all the points that we need. Alright,